Hello everyone, good morning. I'm Javier Sanchez Alvarez. I'm an Associate Director at the Value Analytics Center at AbbVie, and today I will be speaking about WARDEN, which is a package to perform discrete event simulation in R. This is the logo that was created with ChatGPT. I guess I should state that. So the first question is, why WARDEN, right? Why is there the need for WARDEN? Well, you just heard that DES and R are increasingly relevant for HTA submissions, and the issue that I saw was that the existing packages, one may have a non-health economics focus. So you have the Simmer package here for resource-constrained discrete event simulation. It's very fast, but non-health economic focus. It may require knowledge of C++. You have the microsimulation package, very fast, but again, requires C++. And in any case, you would need major work from your side in order to make it fit for purpose, because you need to write a lot of functions to make it work as you wish. So that's where WARDEN comes into play. And the idea was to develop a discrete event simulation, that would be fit for this. And it was developed through my stay at Roche, Evidera, and AbbVie. And I want also to thank them because they have supported open source coding and a copyleft license, so all the code is publicly available in GitHub. And in fact, there you have the QR code, you can scan it, or even later, there is the link on the title. So the idea here is to be first, health economics focus, so you have your interventions, you have your qualities, your life years, your cost. Everything is ready as you would have in an Excel model. It's HTA submission ready. By that I mean that you have a full tool set of things that are relevant for HTA submission, so you can run scenarios, your one-way sensitivity analysis, PSA, etc. It's beginner, between quotes, friendly, because it still requires some knowledge to run a discrete event simulation, right? But it doesn't use C++. And it tries to use these tie-diverse pipes. We will see if I can make that more modular. It focuses on flexibility and transparency as opposed to just full speed. So this is more for you to be clear that the model has no bugs, that everything is clear, as opposed to just make it run super fast. So how to work with WARDEN, and I will not go into the full details. I would just say that in terms of speed, unfortunately, you cannot really vectorize this thing because events sort of make the patient history branch out. And so you just end up with a lot of nested loops, and the approach here was to use delayed execution. So first you would set inputs at different levels. You say, okay, for my scenario analysis, I don't know, for example, you have a time horizon, you set that input, and you set it to a given value, right? Then you would set for the PSA iteration, so maybe a PSA like a parameter. Then you have patient-relevant inputs. There you have, for example, age. Or then you have treatment-specific inputs, which would be like a specific flag whether the patient is on treatment or not. This could also be set from Excel, so you could, I guess is relevant for the discussion from Eileen, where you could actually just import this from Excel and then process them through here. Once you have set up your inputs, you would set the initial time to event. So you say, okay, in my case, you have two arms, arm 1 and arm 2, and you have 3 events, event 1, 2, 3, and you would say, okay, for event 1, the time to event is given by an exponential, and you would define this for each event. Once you have set up your inputs and your initial time to events, you just need to define what is going to happen at each event. So you say, okay, for event 1, for example, the flag, I'm going to set it up to 0. And you would do this for all the relevant events so that you have your model written, essentially. Once you have done that, now you just need to clarify, and this has changed relative to DSM, for example. You just need to clarify which of these inputs are going to be costs, which are going to be qualities, and how are you going to discount them, if they have any discounting. So for example, here I say, okay, it's a utility and it's going to be continuous discounting for this parameter called Q_default. And you do that for the relevant parameters. Now that you have everything set up, right, and you are ready to run the model, you have this runsim function where you plug everything that you have collected before, and you basically run it through, and you execute it. Now, you have to wait, of course. It's relatively efficient, I would say. By my estimation, in a relatively simple or moderate model, it would take it takes 9,000 events per second. So you do the math depending on the number of interventions and iterations that you have. And it uses, under the hood, essentially environments. So it uses no C++ right now. And it uses environments to sort of reassign, because this is the most efficient way to do everything purely in R. And so at the end you get some outputs. In this case, this is for example, but you just have like the full IPD if you want. You could also have aggregate outputs to save some memory. And if you wanted to, not saying that I recommend it as well, you could report this back to Excel. And even, you know, we have done this internally. You could have in Excel call Quarto or call R, run the model with the inputs from Excel and report them back to Excel. So that could be done, and you could do the interactions with, for example, JSON files or things like that. So what are the advantages of using WARDEN, particularly relative to the package that we developed in the past, which was DSEM? So first is that it's faster. It's 2 to 3 times faster because now we're using environments, we're not using lists, and you know, we got some improvements. We expect to have even a bit more speed improvements over the future, but just to make it a reference, in C++, maybe you can run the same model maybe 10 times faster, so you just have to choose well, or whether it's better to learn C++ or just waste a few seconds more. There are no new analyses you can run, so I think in this end we did not have the possibility to run scenarios or to run probabilistic scenarios or probabilistic one-way sensitivity analysis. Now you can. There are numerous helper functions that were not present in DSEM, so you can handle inputs automatically, and I think this is going to come very nicely with the speech that Erin gave before. You can replicate profiles in case you have IPD data. You can summarize the reactions in case they are very long and you just want to have a quick summary. There are statistical functions, so you have conditional quantiles that are relevant. Conditional I'm still alive, what is going to be my time to event in the future. You can adjust the lag in case the parameterization changes. There is a debug mode, so now even on error, it will export a log file where you will see how event items change over time. So you can say, oh, it crashed. Why did it crash? Let me check. Was it a matter of the values? Did I program something wrong? You can evaluate that. It's fully documented, so you have several examples, and I'm trying to expand this on this, so you have any feedback, please let me know. I'm happy to provide more vignettes and examples on the website. It has improved outputs now, so you can aggregate at several levels depending on how much memory, because maybe for a PSA with 1,000 iterations, you don't want to have gigabytes and gigabytes of IPD data around, you just want the aggregate outcomes, right? So you can do that. And also, you can have aggregate outputs over time. So you want to see how your qualities evolve over time, you can do that as well, optionally. Of course, when I say optionally, you activate, it adds a bit of running time, but not a lot. So these are sort of the improvements relative to DSEM. And today we'll focus, I showed you a bit how to run it, and now I wanted to show these 2 functions that I have underscored here, just to showcase a bit how it works. So I think this will go very nice with what Eileen said. So how would you handle all these things of the deterministic, probabilistic, one-way sensitivity analysis and scenarios in a single function to choose all the relevant raw inputs at least? So imagine you have this data. This looks very similar to what Eileen showed before. You have your parameter name, you have your base case, you have the distribution with the parameters, you have, for example, DSA mean, max, you have the scenarios, you also have an indicator sort of column for whether those parameters are going to be active in a PSA, and also another one that is, imagine in a DSA you want to co-vary some of these parameters, not saying that you should, but you could. So in this case, this silly example, I put that age and utilities.sig would be co-varied at the same time in a DSA. You could do that as well. So the idea here was that when you execute the model, if you're changing from a deterministic to probabilistic to a scenario analysis, you should not touch the model itself. You should only touch the runsim function, which is what executes it, right? And so I created this function called pickval that essentially automatically recognizes what you're running and then will pick the right values. It accepts vector parameters, so you could have your Dirichlet, multivariate normal, etc., and you can have multiple variables, parameters covariate, as I mentioned. So this is how it looks. Not very pretty, I know, but if you have 100 parameters, this can be relatively pretty. So you just say, okay, I have what is going to be my base case, right? Deterministic, it would be understood. Your PSA, and then you have this pick PSA function that essentially just calls the distribution, and then you just provide it the parameters, and it will automatically load those. You just declare also what is going to be the sensitivity analysis value, if there is one, and you can see here that it is a variable that comes outside the function, so this comes directly from the model automatically. You have a PSA indicator, whether you're in a PSA or not. You have a sensitivity analysis indicator, whether it is active or not. So you could have both being true. And then you have just these indicators that I was mentioning that determine whether the parameter is being varied or not, in a PSA or not, etc. So how do you actually run this? You use the runSim function, you declare, for example, in this case, I'm running through DSA min and max, and I'm running both PSA equal true and sensitivity analysis equal true. So this would be a probabilistic DSA, probabilistic one-way sensitivity analysis. So what you would get, at least in the DSA min case, is this. You get like the H takes value 40, which is, as you can see, the DSA min value. You take util.sig 0.3, the DSA min value, because the indicators are signaling that those two parameters should be covariate, right? But you could have it, of course, having one by one. And then you have the cos-sig, which takes the probabilistic case, so it takes the PSA. So this function handles everything for you. If you set sensitivity boolean equal to false, now you're in the standard PSA, and it runs everything through, basically creates the PSA values. So this function, sort of, the idea is to handle everything for you, so you just need to define everything nicely. In this case, I put it in a data frame, but actually it's better to use a list, because if you have vectors, then it handles nicely. So I will show you now a very quick example of another functionality that we have, which is, okay, you have your model, it's quite long, you have a lot of interactions in the reactions, etc. So the idea is, how can you summarize everything a bit, so you have an overview and not have to digest, particularly if, I don't know, you are sort of not a great model writer and things are a bit messy in how you write code. If it's a bit of a spaghetti code, then it can be helpful. So knowing, what items, what events are being modified, with what are their definitions, and whether they are conditional statements or not, so whether they depend on an if condition, that could be useful. So there is this struct from reactions event which will summarize all the interactions that you have in the reactions using abstract syntax trees. So that means that it decomposes the calls and says, okay, is this an if condition? Yes. Then what is inside? Is there an assignment? Yes. Okay, what is the assignment definition, etc. And so, for example, this is the spaghetti code I was mentioning. You have multiple ways of assigning a variable. You have this modify item, you have this assignment, you have an assignment to a specific value, you have a for loop, you have a condition there, you have modifying an event, we are creating a new event. You have a lot of things going on, and not in a very pretty way. You run it through this function, and what you get is this. You get just a data frame where you have in a column on which event this item is happening, what is their name, what type are they, so is it an event, is it an item, is it conditional? For example, you see that the y with value w, it's an item which is conditional, so it has the true because it's within an if, and then the definition that it has in symbolic version, so not executed, right? Because this will be later executed when the model runs. And so this facilitates a bit the debugging as well. Not only the debug mode with the export, but this can also help you have an overview of what is going on in the model, particularly if things go wrong and you don't know why. So to summarize, WARDEN expands massively upon DSEM, not only in terms of speed, but also in terms of functionalities that it has. It provides the necessary tools for you that you may need for health economic modeling, and if you don't have those, please let me know. We'll be happy to implement those. It's in C-run right now. We expect to have a new version coming in around 2 weeks with some extra functionalities and making things a bit easier for you. The focus, again, is on transparency, flexibility, and being easy to use as opposed to speed, as I was mentioning. There is some room for improvement, so I would hope to increase the speed a bit, but not a lot, because I don't want to go into the C++, because then maybe, that's when you have to match the types and all of that, and that's a bit messy, particularly if I want to make it user-friendly. And the suite of developments, one would be resource constraints, because right now it's only for non-resource constrained problems, a bit of efficiency improvements and also other features as needed. So for that purpose, of course, your feedback would be welcome, and if you have further questions about how it works inside, etc., I would be happy to discuss those, because it has been a journey to get there, I have to say, particularly in terms of efficiency improvements. So thank you so much.
So we have time for questions if anyone has them in the room.
Yeah, so there's a question in the chat from Showa. Are the graphical outputs, the CIAC, etc. included? And also, do you have a video demonstration of setting a model up using WARDEN?
There is no video yet. I guess I could do one and become a YouTuber. And in terms of, yeah, everything that was in DSM is already included. So EPI and CIAC are both included still. And if you want any other tools, you know, or more recent developments, I can also try to include those as well.
Thank you.
Maybe in the second from the back.
Hi, I'm May. Thanks very much for your talk. Really interesting. I'm interested to know how familiar at this point are HTA agencies with WARDEN?
Well, I mean, apart from the announcement in LinkedIn, I think it's very recent. So we only released it in January, I believe it was. So, you know, it's just picking up. My goal was today to probably showcase it and try to make it more, make people more aware of it. And I guess from now on, now that it's becoming more and more stable, to start to, you know, publicize it a bit more. But yeah, I think we need to work on the marketing side, I would say. Thanks.
Thank you, Javier. How have you validated the package as you've developed it? What tests have you run, etc.?
I mean, you have tests, of course. Then I have some examples. So I have like a cohort Markov example. I have a simple six-secret that you have an early breast cancer example. So there are several examples, and you know, I know that the output should be the same, right, as I increase or change things. So that helps a lot validating. There are some tests, unit tests, of course. And yeah, we have also used it internally in some projects, particularly when I was at the Videra, and there it helped a lot to validate, you know, the outcomes and what we were getting. And also you have the debug mode to understand that everything that's going on is as it should be happening. Because, you know, there are some tricky things, particularly with random numbers and how you handle those down the line. But those have been handled. Yeah. Thanks.
We validated DSM as part of the HTA. So one quick question from Javier.
Again, quick comment. Thank you. That was really interesting. To follow up on the first online question, I wonder whether in the spirit of the wider R-HTA verse, instead of building up and adding more like visualization functionalities or CIACs and stuff like that, we could try as developers to make an effort in having features of your output compatible with existing other tools, so that essentially once you run the model in WARDEN and you've got everything that you need, then it's easy to call existing functions to do the CIAC or the VOI analysis or whatever else. Because that way we are more integrated and it's actually easier to increase uptake for the decision makers, because we kind of cross-validate each other, if that makes sense.
It's a good case, in fact. Probably I should reach out more instead of doing things on my own. And for example, now that we were speaking before about the links function with the drawing of the items, etc., that could also be a great opportunity for collaboration. So yeah.
Because I think the point is that there's lots of strength in having a consolidated body of packages, because otherwise it's just you and the HTA agencies may think, oh, but is this guy good enough, or is this guy good enough, or whatever. Whereas if it's a million packages, then it becomes, oh, well, it's got to be good.
Yeah, yeah, for sure. And plus it goes more in the line of like the tidyverse packages. Yeah, exactly. Yeah, thanks. I agree.
Okay, and let's thank Javier again.